Good morning. I'm going to put together a video today for our Constant of Proportionality flip or foldable. You're going to get this paper today that we're going to fold together like so and make a little foldable that you can have examples that you can use on a test. So what we're going to do is I'm going to go over some of our key terms, go over some equations, go over the tables, and go over the graphs. And then tomorrow we'll talk about how to work through these steps for solving or finding the constant proportionality. So the first thing I want you guys to notice at the very top is it has a definition. What is the constant of proportionality? And so this is going to be a ratio comparing y over x. So when we do this, remember every time yesterday when we started our lesson, it was y value over x value. We'll talk more about those y's and x's down here. And then we're going to use the y's and x's in the table. And then we're going to use the y's and x's for our graph, our x-axis, and then our y-axis. All of it is related in the relationship of comparing y over x. Now, the unit rate is a special constant of proportionality, and a unit rate is going to be something that we've talked about when we go shopping or when we buy pizza, and that's going to be the amount compared to 1. So $6 per pizza means that this is $6 for one pizza, okay? So this is a very special one that we use a lot. We want to figure out how many miles per 1 hour. We want to figure out how many inches per day. It's always going to be our quantity over 1, okay? Now, the constant of proportionality is that letter that we talked about yesterday that we think it should be a C, but a constant of proportionality is going to be our lowercase k, and k is going to be always comparing our y over x, okay? Now, there's 3 ways we can get this: from an equation, from a table, and from a graph, okay? Our equation up here, our equation that we're going to use every single time is what we did yesterday in our lesson. It's going to be y equals kx. So we're going to use this y over x, and we're going to break it apart, put it into our equation where y equals k over x, or how much money would equal $6 per pizza if we order 10 pizzas. So if I do $6 per pizza times 10 pizzas, that gives me $60. So our x and our y are going to be from our table or information. 6 is the constant, never changing. Okay? So this one is beautiful. Our constant, or our k, is going to be the 1/3. It fits right in our equation with our constant k up here. And because there's no extra pieces, it starts at the origin, and that is proportional. This one, we do not have a constant value. I know it's sitting right here, but because of this extra number 1 on the end, this one's going to be non-proportional. That would be like $4 per pizza, but $1 to deliver it to the house. Okay. The next one, beautiful. Our constant can also be written as decimals. So we can have a k constant 6.3, which automatically means it's proportional. And remember, anytime we have a square, that's going to be non-proportional because it's going to give us that parabola shape when we graph it, which is never going to give us anything linear. Okay? So we'll talk more about this one later in the school year, but these 3 right here are our proportional and non-proportional, with our constants k always written with the x. Now, if we want to use a table to do this, it would be a y to an x. We're going to compare a ratio of y to x, and it's always going to be from ordered pairs, which means x comma y when we do a graphing. So to simplify this, we cannot divide by 0, so we have to be very careful. So the last one says if x is 0, we do not make a ratio because we cannot divide by 0. The last thing that we need to look at right here is that I have these ratios. We got to figure out if they're proportional or not. So I have to write a fraction for every single one and see if we get the same answer. So the first one right here has been done for you. They took a y over an x. I'm going to take a y over an x. I'm going to leave the zeros because we can't use that one. We skip that one. And then I'm going to do a y over an x. Each one of these gives me -3. If I get the exact same number, I'm proportional. And my constant is going to be -3. On the next one, we have a problem. We're going to skip because that's our zeros. I have a 2 over 1. That means 2. From here on out, every answer has to be 2. I can stop at the next one because when I do my y over x, I get a 3. The minute these are not equal to each other, not proportional, we don't have a constant. The next one here is going to be a -2 over 5 because I have a -2 and a -5. We skip this one. We do the next one, which is 2 over 5. And we do the last one, 4 over 10, which reduces a 2 over 5. Now, I know we haven't learned all of our integers yet, but this one is actually the same thing. 2 wrongs make a right. So if you look, every single time I did the problem, I have 2 over 5. So that means it's proportional, and our constant is 2/5. Okay? Last but not least is if we have an equation, it's been the easiest one, we can look and find it. A table, we make each of our ratios and see if they are equivalent to one another. The last one is going to be the one that you guys have been working on for graphing. So in order for it to be proportional, the graph must be linear and pass through the origin. Now, I know you guys already know this because we've been working on it in class, so this one shouldn't be a surprise. Now, the constant proportionality, we're going to take it and we're going to divide the y by the x. We're going to divide the y by the x. So our next one down here at the bottom, we have our graph, which means can we check off these boxes? And if we can, what's going to be our constant? So we have our first one. It is linear. It passes through our origin. And now we have to look for our constant of proportionality. So if you look, it's going up and over, up and over, up and over the same amount of times. So it is proportional. And our proportional relationship is going to be rising 2, running 1 each time. Up 2 over 1, up 2 over 1. So that's going to be a constant proportionality of 2. The next one is going to be this U shape. And we have a problem. So our U shape is going to be not linear, but it does start at the origin. Well, the minute we have one of our rules broken, we can say not proportional and move on. Okay? The last one we have here is we have this beautiful linear line. Perfect. But then if I look from my origin, which lives here, my line is not passing through it. So it does not pass through the origin, which again, it means non-proportional. Okay? Now, these examples on the other side are going to talk about how to do it all together. So here's my y's and x's for leaf bunches and white flowers, because we're going to put together an equation that will work for this relationship. So make ratios for all the ordered pairs, and they have to be y over x. So my first one, y over x, is 1 over 4. Then I have 2 over 8. Then I have 3 over 12. And my last one is 4 over 16. All of these, when I simplify them, will be 1/4. I divide this one by 2 to get 1/4. I divide this one by 3 to get 1/4. I divide this one by 4 to get 1/4. So we have a constant of proportionality of 1/4. It says, are they all equivalent? The answer is yes. They all equal 1 over 4. So if I want to write an equation, this is your K. K equals 1 over 4. So my equation will work for every single time. Y equals 1/4 x. It's that easy. Okay? Now I'm going to come down here and I'm going to find out that I have a 0 up to 30 and a 30 up to 60 and a 60 up to 90. So I'm looking at my y's right here. These are your y values. Every time my y values do something, they go up by 30. Now let's go down here to my X values. Here's my X's. I was at 0 for the first one. So when I rose 30 and went over, my scale says 2. My next one goes up to 60 and 4. My last one goes up to 90 and 6. Which means all of these, when I divide each of these, I'm going to get a whole number of 15. You just found the constant, k equals 15. So my equation, y equals 15x. Now the last one is going to be, we got to do it all on our own, and it gave us our lovely little information here. 1 yard equals 3 feet. I want to make the table, make the graph, and then get my equation. So if 1 yard, x is yards, equals 3 feet, I get to fill it in. Okay? So my answers would then be, what if I have 2 yards? What if I have 3 yards? What if I have 4 yards? Because I'm looking down here, 1, 2, 3, and 4. So I'm going to look at this and say, well, if I have every yard is 3 feet, I'm going to multiply this by 3 to get 6, multiply this by 3 to get 9, multiply this by 3 to get 12. So right now, every single time we did something, we have 3 over 1, we have 6 over 2, 9 over 3, and 12 over 4. If I divide every single one of these ratios, I'm going to get an answer of 3, which means I'm going to go up 3 feet and run 1 yard, and go up 3 more feet and run another yard, and go up 3 last feet and go over a yard. It also means if I have 0 yards, I have 0 feet. So that means the origin would work. So now I'm going to graph this and show that it is linear. And my equation, y equals 3x. It means 3 times every x puts me at my y spot. Okay, ladies and gents, your job should have a filled in paper that we are going to fold like so. And you have 3 examples. So if you cut each of these and you can flip it open, there's example 1, example 2, example 3. These are allowed to be used on any test or quiz, and then you are going to use them for our homework from this point on. If you want to color, decorate, highlight during this time, you may. Thank you. Have a great day, guys.